Hi everyone, today I'm going to be talking to you about the template method. The template method is an object-oriented design pattern where a parent class defines a skeleton method which contains high-level steps, and the child classes define the implementation detail of the steps. So because of this, it's typically done using an abstract class. And if you don't know what an abstract class is, basically what an abstract class is a class that can define both abstract methods, which is a method which must be implemented by any non-abstract subclasses, and it can also define non-abstract methods, which is a method that has implementation detail. So in the abstract class, when you are using the template method design pattern, what you would do is you'd have a non-abstract method which served as the skeleton method, which defined the steps that needed to be taken, and then any methods inside that skeleton method that you want subclasses to have to define the implementation details for, you would make abstract, and that means that any subclasses that extend the abstract class must implement the detail of those methods. So yeah, that's how you define the template method. And another thing that's useful to note about abstract classes is you can't actually instantiate them, and that's because they're kind of like a cross between an interface and a class, in that you have some methods which are defined, like the parameters are defined and the output's defined, and the name of the method's defined, but you don't actually have the implementation logic behind it, and that's why any classes that extend an abstract class must implement those, much like if you were implementing an interface, you would implement any methods that's sort of supplied. So yeah, that's kind of like why you use an abstract, one of the reasons you might use an abstract class when you've got some code that you want to provide, some methods you want to provide implementation details for, but others that you want subclasses to. And it's very useful for the template method in particular. We know what the template method is. Let's jump into a really simple example. So I'm just going to create a really simple class here, and I'm going to call it hungry thing. So what I'm going to do is I'm actually going to make this an abstract class, and inside this I am going to define a template method, which will be the skeleton for my code, and then I am going to define some abstract methods that subclasses must implement. So first off, I have an abstract method gather food, and I'm also going to create another abstract method which is going to be to eat the food. And then I'm going to create a final abstract method which is going to be to clean. So it's basically a hungry thing might go ahead and it might gather food, eat food, and then clean up, but different hungry things might have different implementation details. So now here I am defining the template method, and I'm calling it its food time, and this is going to have the actual high-level steps that will be implemented by the subclasses. So it's going to call gather food, then it's going to call eat food, and then it's going to call clean up. We can't implement this abstract class because there are a few methods here that need to be implemented by subclasses. So I'm going to create a subclass, and I'm going to inherit from that hungry thing abstract class. So I'm going to create a human. You can inherit from it the same way you would from a normal class, but it's going to request that you implement the methods that have not been implemented, much like an interface. As you may remember, I've mentioned previously that the abstract class is kind of like a cross between an interface and a class. So for human, when we are gathering the food, or when we're cleaning up, we might wash our hands and dishes. When we're eating food, we might go ahead and we might use a knife and fork. And for gathering food, we might go ahead and we might get our food out of the fridge and cook it up. So that's the what a human that is a hungry thing might do. But I may also want to have a different sort of hungry thing. And let's say I've chosen a lion. So once again, I'm going to be extending that abstract class. And once again, I'm going to have to implement those methods that I have defined as abstract in my abstract class. So this is the subclass implementing the more detailed implementation logic of the template method. So for cleanup, a lion might just lick its paws, and for eating the food, it might just rip into it with their teeth. They don't have any cutlery. And for gathering food, we may actually just be going on a hunt to gather some sort of wildlife. So you can see that I've got the same sort of template of logic, and the same steps will happen when it's food time for both hungry things, but the actual implementation logic of the actual steps is different. So I'm just going to go ahead and show you me writing the code for the template method and what would happen in the different scenarios. So I'm going to create a human. And I'll call it's food time. You could make the cleanup, gather food and eat methods private, and then you wouldn't be able to call them directly. It's up to you what's going to be more suitable to your situation. And I'm going to do the exact same thing for the lion. My code for this is all going to be available online. I'm just going to comment out this singleton code here. So when it runs, you can see that the second part is the lion and the first part is the human. So it's going to go to the fridge, prepare a meal, eat with knife and forks, wash hands and dishes. Then for the lion, it'll hunt prey and it'll rip into it with teeth and then lick paws. So you can see that this it's food time template method has defined a template, and the child classes have defined the implementation logic. So I hope you've enjoyed this tutorial today, and if you have, please like and subscribe for more content.